Hey everyone, this is Krish and hope you're doing well. Welcome to Snowpal's podcast. In this podcast, I want to talk a little bit more about caching and we'll try to pick up from where I left off in the last podcast. But before I go into the podcast, I want to ask you if you got a chance to check out pitch.snowpal.com. If not, I strongly urge you to do so because you're going to immensely enjoy the structure it brings to your life. Having said that, let's get into the podcast. I don't exactly recall where I ended the last one, but I know I did not go into the details of this particular aspect of caching, which is the fact that there almost never is a silver bullet. And what I mean by that is when you try to solve a performance issue or even a scalability issue, it's natural to want to look for that one big bottleneck, and by alleviating that, we hope that everything is resolved and things are working beautifully. That might happen, but it's probably doesn't happen all the time, and it's very likely that it even does happen because in my experience, I've seen that when you're trying to improve performance, if the page takes or the API or the mobile screen, doesn't matter what it is, if it takes like a whole lot of time, like 3 seconds or so, bringing it down to like a half a second is all right. I mean, it's not easy. Nothing is easy, but it's not terribly difficult. And I think I may have mentioned it in one of my previous podcasts. But when you go below a half a second, things get pretty challenging. And then in those scenarios, there isn't necessarily a single place, at least most of the time from what I've seen, where things are going wrong. It's usually a death by 1,000 cuts. And again, what I mean by that is there are many tiers to a particular request, be it an HTTP request or if it's all scoped to the backend services. It doesn't matter, right? There could be a number of things happening within the realm of that or the scope of that request. And now, as much as we might sometimes hope to find that one big bottleneck, like I mentioned earlier, it's rarely the case that was causing a performance issue. It's usually a number of different things put together collectively cause the problem. I was trying to make some optimizations recently, like a couple of days back, for an API that for a web request that ends up calling one or more APIs, and each of them took like over 150 to 175 milliseconds. Now that in itself might not seem like a big number, but generally if something takes longer than 80 to 100 milliseconds, it tends to become noticeable. And if you're very picky like I am, it becomes even more so noticeable. So and again, if you have a couple of APIs and your chain is only as strong as the weakest link. So you want to make sure that none of your API calls take that long, or at least the ones that shouldn't be taking that long. When you're adding new content, when you're doing something like that, it's all right for it to take a little bit longer. But when you're fetching content, you want that to be screaming fast, right? We want all of it to be as fast as possible, but some pages and some screens ought to be faster than others because as a user you're willing to wait that extra 10, 20, 50, 100 milliseconds in some cases but not in other cases. And as I found out and as I'd expected, it was not a single big problem that was adding to that 50 or 100 milliseconds. It was a number of things that were happening. And essentially when you have a distributed application with n number of tiers, it's a double-edged sword, right? We want for it to be that way. Your architecture should be distributed, and we can do a different podcast on that topic entirely. So, but the cons of it being super distributed is the fact that there are multiple hubs, and every time there is a hub, there is going to be some latency, and if network is involved in those hubs, there is going to be latency that you cannot directly control, not all the time at least, right? So what do? You try to minimize the number of those network calls. And again, it's simple to state it that way, but how do you actually implement it, put that into practice in any given scenario? That depends on that particular scenario, on your use cases, requirements, users, volume, and a whole lot of other things, right? But essentially, you want to minimize those round trips, whether it's from your the browser to your web server to your app server, app to the database server, or you could be interacting or integrating with a number of other services in the middle from a backend standpoint. So there could be a number of things that are happening before the user actually sees that page being rendered. By page, I generally mean a web page, and when I say screen, I generally refer to a mobile screen. Just to call out for that distinction, but sometimes I use it synonymously. So in this particular case, I'm just saying As far as the user is concerned, your page is constructed in a what do I say? I mean, they don't obviously care how your page is constructed, but the general expectation might be that your page is all constructed or slash assembled at the same time, but that's not the case. And depending on your framework and the client libraries that you might be using, you could be making requests in parallel and assembling those pages using some templating engines and doing a bunch of things to render the page as quickly as you can, and at least hide the parts that are rendering not so quickly so it's not super obvious or conspicuous to the user. So from a development standpoint, you'll be doing a lot of those things, but ultimately we all want to make sure that the users have a pretty seamless experience, right? So try to reduce the number of hops, and where you have to do those hops, try to find out how you can optimize them. Reducing is one aspect of optimizing it. The other aspect is, yeah, sure, we have to make the hop, but where in that request is the time taken? Is it the time taken by the backend services themselves? Or are you returning large amounts of data? Is your payload that's returned a whole lot larger than it needs to be? Because your page may or may not use all of the attributes that are part of that payload. So you may want to look into those aspects as well. So your APIs only return what you want for them to return. If you're using REST, it's a little more difficult. If you're using GraphQL, it becomes much easier. So, obviously if you're writing something new, I love GraphQL. I highly recommend it. But, a lot of times we have a combination of REST and GraphQL APIs because we may have started that a little while ago, and we are either, it's not always easy to migrate in entirety. So you migrate certain aspects of your application, you port them over to these newer stacks and newer methodologies and protocols and design patterns. So you don't want to rock the foundation. You want to keep your product stable. So you establish that trust with your clients, and then you want to make these improvements. And a lot of times the framework improvements are not seen necessarily by the end user. They wouldn't care whether it's Bootstrap 3 or 4, but you want to keep yourselves up to date in general, because if you're on a version of Ruby or a version of Node that's far behind, then you're not going to be able to leverage the NPM modules that actually have a dependency on that version as well. Now, none of that, I realize the last 3 minutes or maybe 2 minutes of what I said has little or nothing to do with caching. That's part of what I need to learn in terms of sticking to a particular topic when I'm doing this podcast. But I just want to convey this aspect of my thought process today, which was don't always look for that one single big problem when you're optimizing. It might be a combination of many things that cause a problem. And I'll go into a little bit more detail about that particular aspect maybe in a subsequent podcast. But hopefully some of this made sense to you. Thanks for listening. Bye-bye.